Hey, this is Miss Landau. Today we're going to be learning about patterns in zeros and decimals. The standard we're working on today is explain patterns in the number of zeros of the product when multiplying numbers by powers of 10, and explain patterns in the placement of the decimal point when a decimal is multiplied or divided by a power of 10. Use whole number exponents to denote powers of 10. Our essential question is, how can I use exponents and patterns to multiply by powers of 10? Let's activate our prior knowledge of exponents. 7 times 7 times 7 equals 7 to the third power. 7 is our base number, and 3 is our exponent. So 7 to the third power just means 7 times 7 times 7, or 7 multiplied by itself 3 times. Just the number 7 would be the same thing as saying 7 to the first power, because there's only one 7. 10 to the first power is the same thing as just saying 10, or 110. 10 to the second power is the same as doing 10 times 10, or 10 multiplied by itself 2 times. 10 to the third power equals 10 times 10 times 10, or 10 multiplied by itself 3 times. 10 to the sixth power is the same thing as saying 10 multiplied by itself 6 times, or 10 times 10 times 10 times 10 times 10 times 10. Practice makes perfect. 3 times 100 equals, well, we know that's 300. But I wrote it again, 3 times 100 equals, and I put that decimal point there. I want us to pay attention to where the decimal point is when we write the number 300. We have the decimal point at the end of those numbers, 300.0. We have 300 and nothing else. We had the decimal point right after the 3. So let's see how many places it moved. 1, 2. 1, 2. And we had to add another 0 there. So 3 times 100 equals 300. This is the same way to write 3 times 100, 10 to the second power. We know that we have 3. Then we need to move that decimal place 2 times because we need to add 2 place values. 300. 2.5 times 100, we would also move the decimal place to the right 2 times and fill it in with zeros. So 2.5 times 100 is 250. 2.5 times 10 to the second power is the same thing. 10 to the second power is 100. So 2.5 times 10 to the second power is 250. All right. 6 and 7/10 times 10 to the second power. 6 and 7/10 times 10 to the second power means I need to move my place value up 2 spots because of this 2 exponent right here. 1, 2. Since there's nothing there, I need to add a 0. So I know that 6 and 7/10 is the same as 670 because I went up 2 place values. 8 and 31/100 times 10 to the fourth power equals, well, 8 and 31/100, 1, 2, 3, 4. I'm going to move that decimal place over 4 spaces, and I have 2 zeros there. So I have my decimal place at the end now, and my answer is 83,100. So since I moved over 4 places for 10 to the fourth power, 1, 2, 3, 4, I know that 8 and 31/100 times 10 to the 4th power equals 83,100. Let's do one more. 892 thousandths times 10 to the 5th power equals, I'm going to write it down here so that I have enough room, 892 thousandths times 10 to the 5th power. So I know I need to move my decimal place over 5 times since I'm going to have to move my place value up 5 times. 1, 2, 3, 4, 5. Add the zeros where there's not a number. And I know that 892 thousandths times 10 to the 5th equals 89,200. It's your turn to show me what you know. Please screenshot and send me your thinking. Have fun!